passing through the slits is transmitted or blocked accordingly. So the light will convert it into an electrical current in the detector elements, which corresponds to each slit, and the output is as an two square waves. So the two slits are positioned so that the phase difference between the square wave outputs is to be 1 by 4 pitch. And the type of encoder outputs a pulse string in response to the amount of rotational displacement of the shaft. Okay, to detect the amount of rotation from a certain input shaft position, the count in the counter is reset at the reference position, and the number of pulses from that position is added cumulatively by the counter. So when you are saying about the advantage disadvantages, actually the incremental encoder is much simpler since it has only one track and one set of emitter or detectors or brushes. Similarly, the direction of rotation for incremental encoders can also be a problem since the pulse do not indicate the direction. Bidirectional incremental encoders generally have two tracks placed so that the pulses will be 90 degrees out of phase with each other. We have to be about an absolute optical encoder. Actually, when a disk with the pattern rotates, the light passing through the slits is transmitted or blocked according to the pattern. The received light is converted into an electrical current. The detector elements takes the form of waves and becomes digital signal. So whereas this type of encoder outputs in parallel the rotation angle as an absolute value in the encode code. It therefore which has one output for each output code bit, and as the resolution increases and the value of output increases. Rotation push reduction is accomplished by directly reading the output code. When the encoder is incorporated into a machine, the zero position of the input revolution shaft is fixed, and the rotation angle is always output as a digital value with the zero position as the coordinate origin. So the absolute encoder, which has several tracks that are binary encoded, so that the total shaft angle can be determined. The absolute encoder needs no synchronization or direction capability. The actual shaft position is available at all times by reading the binary coded word from each of the emitter detectors or brushes. Similarly, the disk of the absolute encoder which has a track for each bit of digital word representing the shaft position. The most significant bit is weighted at 180 degrees, and the next bit is weighted at 90 degrees. The next bit is weighted at 45 degrees. Each track has an area of proportional to its size. The most significant track will be on for half the circumference and half for half the circumference. The next track will be on twice and off twice at 90 degrees spacing provided over on it. So we'll have an additional disk that gives a number of revolutions. It consists of gear wheel strain, and we'll have a main disk that gives a position over 360 degree rotation. So this is about an absolute encoder. Okay. So this is about an encoder size over on it. Okay. The next thing actually we have to see about an magnetic sensors. So magnetic sensors, the thing is to be that which can detect changes and disturbances in the magnetic field like flux, strength, and direction. So whereas in the case of an other types of detection sensors, which works with characteristics like temperature, pressure, and light over on it. So from the established knowledge about the existing magnetic field and the data collected from sensors regarding changes and alterations, many things can be known. Okay, rotations, angles, directions, presence, and electrical current, which can also be monitored. When you are saying about the magnetic sensors, that can be divided into two groups: those that measure the complete magnetic field and those that measure the vector components of the field. The vector components are the individual points of the magnetic field. The techniques which are used to create these sensors involve various combinations of physics and electronics. So what are all the terminology that we use in the magnetic sensor? The first one to be the magnetic field intensity. Usually will be denoted by means of an H, so which can be named as a magnetizing force, or it can be named as a magnetic intensity. That is the part of the magnetic field in a material that arises from an external current, and it is not intrinsic to the material itself. It is expressed as a vector H, and it is measured in units of amperes per meter. Whereas the case of a magnetic flux permeability, so the thing is to be that is the amount of magnetic flux to a unit area taken perpendicular to the direction of the magnetic flux. Also, it is called as a magnetic induction. It is expressed as B, and it is measured in Tesla. Okay. The next thing we have to see about an magnetic permeability. Okay, so when you are saying about an magnetic permeability, so that we can about the magnetic permeability and what are the factors affecting magnetic permeability, that we can see in the next class. Thank you all.